Hello everyone, in this experiment I'm going to do resistors in parallel. Objectives: to determine the equivalent resistance of three resistors connected in parallel. Apparatus, power supply. Instead of switch, I will use the switch of the power supply to reduce the number of wires in the circuit so the resistors will be less. So I will use the switch of the power supply instead of external switch. Connecting wires, 4 ammeters, 3 different resistors, 20 ohms resistor, 15 ohms resistor, and 5 ohms resistor. Set up the circuit as shown in the diagram. We start from the positive terminal of power supply to one of the ammeters. Now, from the ammeter to the 3 resistors. Now, here, so from the ammeter to the 3 resistors. So this is a junction. I will take this as a junction for the 3 resistors. Let this one, this resistor is R1, and then this is R2, 15 ohms. R3, 5 ohms. I connected the 3 resistors. This connection in parallel. Now I connect it to the ammeter for each one. So the first one to the first ammeter. So this one here. And from the second resistor to the second ammeter. And from the third resistor to the third ammeter. The other terminals of ammeters are connected together as a junction. Then I connect this one to here. So it's black, no problem for black or white. It's better. I use the black one. So from this ammeter to this, and from this ammeter to that one. Finally, from the ammeter to the power supply. We check the connection. From the ammeters, it's here. Yes. Now the connection is perfect. This is the main current, but it's very high current here. I used the 500 milliampere, so I reduced it I increased it to 5 ampere because this is the main current. So this is I, the main current, and this is I1, I2, I3. We start to take the reading. First of all, I register R1, R2, and R3. So this is the first one, R1, it's 20 ohms. R2, it's 15 ohms. R3 is 5 ohms. The reading of ammeter. When I read the ammeter, I have to look direct to the needle of ammeter. So now I take the main reading, the main current. So I 0.5. This is the main current, the current from the circuit or the current in. Now this is the junction. This is the junction. Distribute the current over R1, R2, and R3. Now I read I1. What is I1? It is the current through the first resistor, 20 ohm. So I1, 85 milliampere. Multiply 10 power negative 3 to be ampere. Switch on. I take the second reading. 115 milliampere. Multiply 10 power negative 3. I3. So it is 356 milliampere. 356 multiply 10 power negative 3. Okay? We know that when the resistor decreases, the current increases in the resistors when the resistor is connected in parallel. Okay? So, because it is the same voltage here, the voltage is the same for all, but now the current depends on the resistance. More resistance, less current. 20 ohm resistor, the current is 85 milliampere. 5 ohm resistor, the current is 356 ampere. So it is inverse relation between the current and the resistance. I calculate resistance. So I write R. R, it is V here. This V from power supply, it's 2 volt. This is the calculated resistance. R equals V total, which is 2 volt from the power supply, over the main current, which is 0.5. 2 divided by 0.5 equals 4 ohms. Now we calculate the equivalent resistance. Because the resistors are connected in parallel, so we write R total equals 1 over R1 plus 1 over R2 plus 1 over R3 all to the power negative 1. 1 over 20 plus 1 over 15 plus 1 over 5 all power negative 1. R total is 3.2 ohms. The calculated value is 4, but the equivalent resistance is 3.2. So the calculated value is more than the equivalent value of resistance. 4 divided by 3.2 equal, it's 1.3. Then the calculated value is 1.3 times more than the equivalent value of the resistance. What is the relationship between the currents through the resistors and the total current? The total current we measured here in the table, the total current was 0.5. We calculate I1 plus I2 plus I3. This is a junction. The current in, this is Kirchhoff's first law. The current in must be equal the current out. Now we calculate the current out. It means we calculate I1 plus I2 plus I3. It's 85 plus 115 plus 356 equal, multiply by 10 to the power negative 3 because all the readings was in milliampere. It is 0.6 ampere. I1 plus I2 plus I3 is 0.6 ampere. We note that the current in 0.5, the sum of currents out 0.6, approximately the same. But what is the relationship? I, the main current or the current in, equals the sum of currents out about the, so the sum of currents entering the junction equals the sum of currents leaving the junction. It means we verified Kirchhoff's first law. Now, what is the conclusion of this experiment? We did experiment to verify that 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 in case of resistors when they are connected in parallel. We did that experiment. R total, the calculated value was 4 ohms, but the equivalent value was 3.2 ohms. So the calculated value is more than the equivalent value of resistance. But why this happened? Because actually a lot of wires we used, that wires have resistance. Then that resistance added to the equivalent resistance. For that reason, R calculated is more than R1 plus R2 plus R3 because sum of resistors will be the resistance of the wires. Also, we verified in that experiment Kirchhoff's first law. At any junction of the circuit, the sum of current entering equals the sum of current leaving. I hope you understand this experiment. Thank you.